Good morning, everyone. Today we are going to learn section 4.2, which is about exponential functions. We learned earlier in 0314 about exponents and the rules, so we know what exponents means. Today we are going to learn how to graph exponential function and how to evaluate the exponents. So you may have to watch the other videos I have posted on ConnectMath to learn how to use your calculator, because I do not have access to graphing calculator on my device which I'm using to teach here. So you have to use those videos only for learning about graphing. So I might explain how to do that in the middle as well. So the first objective is graphing exponential functions. So number one, you're going to learn how to graph f of x equals 3 to the power x. So you can enter this on your calculator, like you have to go to y1 equals, put 3, and then use the power symbol, and then press x. Then it's going to display this graph. So we need points to graph. That's all we need. So I'm going to, if you access, so after you enter, press second graph, then you should be able to see the graph, what I'm doing here. So we need like 5 or 6 points. So for 0, I'm getting all the points. So 2 is going to be 9. -1 is going to be 1 over 3, which is 0.333. And -2 is going to be 1 over 9. Okay, so let's, we can access the table. So I just roughly draw the graph here. So I'm going to plot the points what we have here. So 0, 1, -1, 0.003, and then 1 is 3, and 2 is 9 somewhere here. 9, so the graph is going to, and when it goes to the negative number, it's going to go almost touching the x-axis. Okay, so let's go to see next example where x to the power is negative. So we're going to graph f of x equals 2 to the negative x. So again, enter on your calculator, get the values. And the graph is So it's going to come like this. Okay, so this is our second example. And the third graph is going to be some translation. So it is 1 minus 2 to the power x plus 1. So the table. One zero, 2, and so the graph is going to go like this. Okay, so it's kind of pretty straightforward. You can look at your handouts as well to get all the information. And then we are going to evaluate the exponential function with base e. So like e to the power 2. So to access your graphing calculator, I'll just write the steps. So you have to, on your graphing calculator, you have to press second ln. That's going to give you the e, then put the power. So this is just approximate the evaluating the values you can use by using the calculator. So this is the answer. So these are the steps you have to use on your calculator. So number 5, we have e to the negative 3. So you press second ln and then put the power, so you get this answer. Okay, and same as e to the power square root of 7. We are approximating the values. And we can put the e to the power pi as well. The pi is on the calculator as well. You can check pi. Okay. So to get the pi, so it's second, this power symbol, this gives you the pi. Okay. Next, to graph the e to the power, graphing exponential function like this, f of x equals to the power x plus 1. So you have to go to y1 equals and then press second ln, then it's give you e, then put the power so we can graph. So I'm going to put the table here. So 0 is 2.7. And the graph is here. So the graph goes like this. Okay. So next we are going to see some application problems. So we're going to use exponential functions to compute the compound interest. So I have there are three formulas when you are computing the compound interest, or the first one is the simple interest formula. So the first one is I equals P times R times T. And the second one is, this is the simple interest. And the second one is A is going to be P times 1 plus R over N to the power N times T. This is for compounding periods per year. And the third formula is A equals P e to the power RT. This is for continuous compounding. So here, where A is the amount, interest amount, and P is the principal amount, and AR is the rate, and T is the years, number of years. Okay. So we are going to use these formulas to calculate or compute the interest. So we are going to do number 9 from the handout. So from the handout, I'm not writing the problem. You can check the handout on Canvas. So the P is given as 15,000. It says, suppose that $15,000 is invested with 2.5% interest. So you have to convert the interest, the percent to decimals, which is going to be 0.025. You have to basically divide this 2.5 by 100 under the following conditions. And then the T is given as 7 years. So part A, if the interest is compounded annually. Annually means every year. So yearly means T is going to be, P is the same. So I'm going to write all the amount here. P is the same, R is the same, 0.025. And N is going to be 1 because we are compounding every year. That means 1. And T is going to be 7. So we have to use the formula number 2. So by formula number 2, the amount is going to be P times 1 plus R over N to the power N times T. If you are using calculator, be careful because we have to use different brackets, or you can use one step by step. You can calculate 1 plus R over N, which is 0.025 over 1 to the power N times 1 T. So we get, when we use the calculator, we are getting the amount to $17,830.29. So this is the amount in the account at the end of 7 years. Okay. Next, problem B is compounded quarterly. So that means let's write all the values here. Everything is going to be the same except for the n. So n is going to be 4 because it's compounded quarterly, means 4 times a year, every 3 months. So we're going to use the same formula for finding the a. So plug in the numbers for each letter and use your calculator. 7 times 4. If you use calculator, the amount we are getting is $17,858.96. Okay, this is for part B. Part C, we have compounded continuously. Okay, again, P is 15,000, or there is no N here because we are not compounding over the periods, it's just continuous compounding. That means we have to use the third formula. Times e to the power 0.025 times 7. So we get 17,868.69. This is for part C. And number 10, again, we have a word problem here. So again, please use the handout. So I'll read the problem. Weapon grade plutonium is composed of approximately 93% plutonium. The half-life of plutonium Pu-239 is 24,000 years. In a sample originally containing 0.5 kilograms, the amount left after T years is given by this function. We are given a formula and we have to calculate whatever the question is. Let me read the question. T over 24,000. Now evaluate the function for the given values of T. So part question A is we have to find A of 24,000 because it says it's T. We have to substitute T equals 24,000 in the formula. So it's going to be 0.5 times 1/2 to the power. T is 24,000 divided by 24,000. So the power becomes 1. So we get just 0.15 times 1/2, which is going to be 1/4. So after 24,000 years, the half-life remains as 1/4 kg. Okay, so this is the answer. And then B, we have to calculate A of 72,000. So plug in 72 for T. More 24,000. So we get 0.5 times 1/2 to the power 3. So the answer is 1/4. 16 kg. This is the answer. Next, number 11. It says a problem says a 2010 estimate of the population of Mexico is 111 million people with a projected growth rate of 0.994% per year. At this rate, the population is given by the formula. So always these formulas are going to be given for you. So our job is just plug in the numbers and get the values. So where t is the times, so t is the time since 2010. So the beginning year is 2010. So that is the most important thing here. So first one, we have to evaluate P of 4. That means t is going to be 4. So P of 4 is going to be, so you have to enter these numbers on your calculator, and t is 4 here, get the values. So we get P of 4 is going to be 115. That means now the answer is going to be different because it's starting from it starts in 2010. So in 2014, so the answer has to be in 2014, the population is going to be, the population of Mexico will be 115 million. So this is the final answer. Okay. So part B is evaluate P of 75. So P of 75 equals, so replace the T by 75 here. So that is going to be 233. So the answer is in 2085 because we have to add 2010 plus 75. So in 2085, population of Mexico will be approximately 233 million. Okay. So that is end of 4.2. So I'll see you in 4.3 section. Bye.